Hi. The day after the Padappakara trip was very exciting. As usual, I went to the geology department like around 9 o'clock, and of course, Professor Menon was in his seat. I said, "Good morning, sir," and he asked me then to get the assistance of the sub-staff in the department to get the samples that we collected from Padappakara section back to the workbench in the laboratory. The workbench is the first stop where we unwrap the samples, arrange them for an initial inspection so as to also chart out the subsequent investigations or pre-processing of the samples before documenting the details. And of course, very promptly, the samples were brought up to the workbench from the garage in the boot, from the boot of the car. And of course, the materials looked very curious. The other teachers also, like Rajendra Nair and Raju Philip, they also came and had a glance of the packets wrapped in English or Malayalam newspapers several times. And of course, every pack had at least two labels, identical labels. Those days there was no indelible ink of any sort, so we had to rely on the old-fashioned method of writing with a pen and a color pencil sometimes with the ID of the samples. And once the samples were unpacked and arranged in the workbench, I reported to Professor that the samples are ready. So Professor told me that, he will join me after a while because he had something else he was busy with. Then what I did was I went to the library and started reading about, the pre-preparation, pre-processing, etc. of sedimentary rock samples that are described in the Manual of Sedimentary Petrology by Cramban and Petillon. That is a classic book which is published in 1930s. And, most people who are avid sedimentologists would never miss this title. This book is useful, and this book was actually a donation by Professor Menon to the Department of Geology Library. That is very special situation. Because this is one of those books he purchased when he was a student in the Yale University in New Haven, Connecticut. Okay, now, when Professor came in, of course, naturally, then the lab assistant, Padmanabha Pulla or Sami will also be there promptly. And Professor Menon wanted Sami Padmanabha Pulla to get the newest edition of the optic lab, a binocular microscope, a size binocular microscope. It came to the zoology department of K.K. Nair for some reason, because Professor K.K. Nair had some kind of a liaison with an American funding agency, and he finally ended up, the zoology department ended up with redundant binocular microscopes. Because K.K. Menon was a good friend of Professor Nair, K.K. Nair rather, finally this microscope was transferred to the geology department. And, I was just watching what Professor Menon was doing. He had a little notebook. He had put the date, etc., everything, all these, then the sample ID, and then went on checking the smaller pieces and slabs of the shaly rock. Those samples of the shaly sediment that are under beneath the Koilon series, Koilon limestone proper. And of course, the entire thing, the shales plus limestone made the Koilon series. And of course, we did not collect any sample of laterite, which is younger to Koilon series, or the Koilon limestone rather. And Menon sir had spent something like half an hour with different samples. I was watching very keenly what he was doing. And he said, all right, now you can take a look at it. So I had no special knowledge of anything, any sort. So yet I ventured into looking at or inspecting the bedding surfaces under the microscope. It was a wonderful view. You could see so many things otherwise which would not have been visible. And then my attention was more on the little and broken piece of limestone rather than on these shales, because limestone was very attractive to look at, because firstly, it is actually a host of so much dust, hundreds of broken pieces of shells, fragments, rather white in color, as well as a host of foraminiferal tusks. This was very interesting to me anyway to start with. So I also had spent about an hour. Then of course one thing is, once Professor Menon left the workbench, Padmanabha or our Sami also retracted to his seat. That was no problem. And I did not take any notes or make any notes because I was not that trained in as to do. I just took a closer view under the binocular microscope of all these specimens. And especially, I had a very keen interest in the limestone. Then, of course, I packed up everything and covered the microscope with a plastic cover that was supplied by the manufacturer himself or came along with the microscope. And I told Sami that I am going to spend the afternoon also with the microscope, so the microscope need not be put back in the almirah or in a safe keeping. So then I went out on my bicycle, went to the coffee house, had 2 puri, masala and cup of coffee, and that was my lunch on that particular day. Then it was only 50 paisa those days, remember? 50 paisa, half a rupee, a puri masala set with a coffee from the India Coffee House. Then I just went into the library and started reading about, what do you do with the carbonate rocks? Those days, I think Springer had brought out a series of books on developments in sedimentology in a common title, Developments in Sedimentology. One of those books, one of those volumes, had a title about carbonate rocks. In fact, there were three different titles on carbonates, or rather 2. One on modern and the other on ancient. In the one on ancient carbonates, of course, the carbonate rocks one. So that volume I took and went through the introductory part, went through the content part. And there was an article about the limestone and how to get new information from the insoluble residue or non-carbonate material in the rock. That was what my attraction was. It was written by Andrew Ireland. Andrew Ireland is a big name in carbonate sedimentology, in the working for the what is called Kansas Geological Survey. And of course, those geologists who worked for Kansas Geological Survey shared a faculty position in the University of Kansas Lawrence. That is, a wonderful arrangement. The students are the most important beneficiaries out of this arrangement, I believe. And in there, Mr. Andrew Ireland, he was talking about the insoluble residue, how to collect the insoluble residue from the limestone. The insoluble residue is the non-carbonate material, mineral matter in the rock. So it is very simple actually, you use use dilute hydrochloric acid, some 20% or whatever, and then dissolve all the limestone. Limestone becomes, the calcium ion becomes joins with the chloride and becomes calcium chloride, and it is suspended in the supernatant water, where the non-carbonate stuff will be sticking to the bottom. And of course, naturally, you have to have the carbonate rock pieces as not larger than 2 centimeter sized ones. In other words, you get the reaction going faster, and within 24 hours, we get the most of the carbonate material in solution. So I did that in a 1 liter or 2 liter, not 2 liter beaker, I suppose. And of course, I have no problem with the access to any of the material in the chemical laboratory of the department, because I had a special position, because I was supposedly working for Professor Menon, head of the department. That is the position. And then, of course, the one set of sample pieces were dissolved or reacted with the dilute hydrochloric acid. One day it was left to stand on its own, and the next day it was the supernatant water was drained off or decanted, and this residue, which was not carbonate material, instead it is all silicate and oxide minerals or whatever, that will not be attacked by dilute hydrochloric acid, was retrieved. It was washed, cleaned several times, and very carefully not to lose any particle down the drain. And then it was dried in what is called in a hot air oven. I remember the name, Garen Camp, that is the name of the oven brand. It was the import actually. These things are very, geology department had the advantage of having received the large portion of modern, those days modern books and laboratory equipment, including microscopes. Then, of course, this was dried. Then, the procedure is to seal it using test seals, so that uniformly sized particles are separated and packed together. So the subsamples were then packed very carefully with labels like what was the mesh size, and then what was the original sample size. And once this is done, the next step is to check out under the binocular microscope, the what is called the appearance in 3D. Binocular microscope was an excellent piece of equipment those days, and it had a very high magnification you can achieve. There is a changing nose piece for the microscope. So, how do you do that? You don't mount these little particles of mineral matter in a glass slide as usual. Instead, what is done is, in a glazed porcelain plate, say 4-inch by 4-inch in size, we pour the portion of the particles, mineral particles, and arrange the mineral particles along a line, and as if it is like a train of one single grain, each one behind the other, so that you can take a traverse and watch each grain very carefully. I was doing that. Surprisingly, opaques are very easy. Black opaques, ilmenite over magnetite, whatever. And then garnet was very easy to identify, and quartz was also very easy because you could see the conchoidal fracture, then altered feldspar. And now and then I saw a grain which is something like a pyrite, in the appearance, but very tiny single crystals or aggregates of microcrystals, or even what you call as later we call the framboids. In other words, aggregation, spherical aggregates of, like a berry of crystallites of pyrite. And of course, this pyrite was a very interesting observation. And of course, then I invited Professor Mehra to take a look at it. Professor did not agree that it was pyrite. I wanted me to verify whether it is pyrite. Okay. So the pyrite story will come later. Thank you. Bye.